So we're discussing polar form of complex numbers. Right now we're talking about significance of polar form. So write down these couple of theorems, which is that if Z1 is a complex number in polar format, which is R1 bracket cos theta 1 plus iota sine theta 1, and Z2 is another complex number in polar form, which is R2 cos theta 2 plus iota sine theta 2. So if you have two complex numbers in polar form, you can conveniently multiply them. You can conveniently divide them. And you can conveniently give any particular power to the complex number. Okay, now how do you multiply them? To multiply two complex numbers, if you have them in polar form, what you do is you multiply their r's. So you get r1 times r2, and in the bracket, you get cos, you add their angles, theta 1 plus theta 2, plus iota sine theta 1 plus theta 2. And the result would be the multiplied complex. Similarly, to divide, what you do, you divide the r's and then you subtract the angles. And to give any complex number a particular power, what you do, you give the same power to r, and with the angle, you multiply that. N theta 1 plus iota sine n theta 2. So if these were not in polar format and they were in regular format, so multiplication is not that complicated, honestly, but division takes a relatively more time. In the end, you have to rationalize it. You have to multiply and divide with the conjugate pair. Remember, go back to the first lesson. Just remember discuss kiya tha कि if we're dividing 3 plus 2 iota with, let's say, 1 minus 2 iota, then you have to multiply and divide with the complex conjugate. So you don't have to do that in polar format. You just divide the r's and subtract the thetas. And similarly, to give a particular power to the complex number, for example, if the value is 3 plus 2 iota power 5. So how would you do this in regular format? Would you write 5 brackets, 3 plus 2i, 3 plus 2i, 3 plus 2i, 3 plus 2i, and then start multiplying them? That would be way too time consuming. So instead, you change it into polar format and then you apply this theorem, where you just give the same power to r and then you multiply the thetas with the same power. Okay, this has a particular name, this theorem. It's called de Moivre's theorem. Not let me just D. ऐसा कुछ नाम है, de Moivre's theorem. Okay. So now let's apply this theorem on the questions. So you have a complex number S already in polar format. Sometimes in the question, they will first ask you to change it into polar format, and sometimes you will already have the number in polar format. So that's S, a complex number, is another complex number T, which is just cos pi by 4 plus iota sine pi by 4. And then there's another complex number U, which is 4 bracket cos minus 5 pi by 6 plus sine minus 5 pi by 6. Plus iota sine minus 5 pi by 6. Okay. Now the question is part A, find ST. So we apply that theorem where you have to multiply the r's of S and T. So that's going to be 2 times 1. And inside, you have to add their thetas. So we have cos pi by 3 plus pi by 4 plus iota sine pi by 3 plus pi by 4. So that is going to be what is pi by 3 plus pi by 4. It's 7 by 12 pi. So we get 2 times cos 7 by 12 pi plus iota sine 7 by 12 pi. Okay. You must always check whether the angle that you're getting after adding, subtracting, etc., is that within pi to minus pi. Is this angle between pi and minus pi? Is the theta between pi and minus pi in this case? Yes or no? Pi से छोटा है, pi से बड़ा तो नहीं है. It is smaller than pi because it is some fraction of pi, 7 by 12th of pi. So definitely it's smaller than pi. If it were 12 by 7 of pi, then it would be bigger than pi. ठीक है, तो इसका ध्यान रखना है. Whenever in the answers, if our theta is bigger than pi or smaller than minus pi, then we have to do a bit of adjustment to get it to be between pi and minus pi. But this is not that particular thing. Achha, not that it's being asked in the question, but what if you're asked to give your final answer in the regular form, not in polar form? So अब इसको regular form में कैसे change करें? Part B, state ST in rectangular form कहते हैं या regular form कहते हैं? Rectangular / regular form. How do we do this? जैसे कल मैंने क्या होमवर्क दिया था, that change 3 minus 2 iota into this format, r cos theta plus iota sin theta. How do you go back from here to here? By simply multiplying 2 and cos 7 by 12 pi in the calculator, it will give you an integer answer. And then multiply 2 with sine 7 by 12 pi. That's all you have to do, and you get it back in the regular format. Okay, let's see what we are getting here. So give me 2 times cos fraction 7 by 12 pi. That is, I'm going to press ST. So I'm getting minus 0.517, well, get 8 after rounding. And what is 2 times sine 7 by 12 pi? That is plus 1.93 iota in 3 significant figures. Okay, so you can always go back from the polar form to the original form by simply multiplying r with cos term and r with sine term. Okay. So एग्जाम में आपको ये भी कह सकते हैं go from here to here, this is what you did in homework yesterday, or they can ask you to go from here to here, which is just case of multiplication, that's all. Okay, so that was part A. Part B is S divided by T. So what do we do for this? We divide their R's. So R for S is 2 and R for T is 1. So 2 divided by 1. And then inside we subtract their theta. So cos pi by 3 minus pi by 4 plus iota sine pi by 3 minus pi by 4. So we get 2 times cos, we get pi by 12 here, plus iota sine pi by 4. So is this between pi and minus pi? Yes, it is. Dividing pi into 12 parts, so it is definitely between 0 to pi. Okay, this was part B. Part C. I need to clear this. Part C is S times U. S times U. So that is going to be multiply the R's of S and U, that is going to be 4 times 2, 8. And then add the theta. So cos pi by 3 minus 5 by 6 pi plus iota sine pi by 3 minus 5 by 6 pi. So pi by 3 minus 5 by 6 pi is minus half pi. So 8 cos minus half pi plus iota sine minus half pi. That is S times U in polar form. Okay, part D, which is U upon S. So let's divide the R of U and R of S. So that's going to be 4 upon 2. And then subtract their thetas. So we get cos. Theta for U is minus 5 by 6 pi minus pi upon 3 plus iota sine minus 5 by 6 pi minus pi by 3. So we have 2, and then we have minus 5 by 6 minus 1 by 3 is minus 7 over 6. Okay. We must take a look at the theta before we move on. Is this theta between pi and minus pi? It is minus 7 over 6 is 1 point something. It's minus 1.165. So no, it's not within the given domain. ये तो minus pi से छोटा है, so that's going to be a problem which we need to fix. Okay, अब इसको कैसे fix करें? Just give me a second. Okay. Okay, so where's this angle? It's a negative angle. Let me just plot it. So it's a negative angle and it goes beyond minus pi. यहाँ कहीं है क्या? Okay. So this is minus 7 over 6 pi, which is not acceptable because the acceptable pi should have been between 0 to minus pi at the negative side. So instead what we'll do, we will instead consider this angle. हम ये angle ले लेते हैं because that would be between 0 to pi, which is acceptable. So now what do we do? The whole angle is 2 pi. From 2 pi, subtract this angle 7 by 6 pi. That would be minus 7 by 6 is 5 by 6 pi. So we're going to write this angle instead. Instead of writing the clockwise angle, we're going to write the corresponding anti-clockwise angle. And both of these would give you the same answer. So 2 bracket 5 by 6 pi plus iota sine 5 by 6 pi. This would be the final answer after dividing u1. That is correct. Any questions so far? Make space for part E. So part E is P upon U. So R for T is 1, R for U is 4, so 1/4 is the new R, and then we subtract their respective theta. So cos, the theta for T is pi by 4, that's written first, and then minus the theta for U, which is minus 5 pi by 6. So we have double negative sign here, plus iota sine pi by 4 minus 5 pi by 6. So that is 1/4 of pi by 4 plus 5 by 6. That is 13 by 12. Plus iota sine 13 by 12 pi. Before we move on, we must stop and check whether the theta is within the appropriate range. Is it between pi and minus pi? It is clearly not, because 13 by 12 is 1 point something. So it is 1 point something pi. So it's bigger than pi, not acceptable. So let's find the corresponding negative angle. If this is greater than pi, so it's going to be somewhere over here. Yahan pe hoga, it's beyond pi, right? It's 13 by 12 pi, which we can't accept because according to convention, the theta, positive theta must be between 0 to pi. Instead, we're going to write this negative angle, which is simply 2 pi minus 13 by 12 pi. And whatever is the answer, we have to write it with a negative sign because conventionally we represent clockwise angle with a negative sign. So we have 2 minus 13 by 12. It's 11 by 12. So 11 by 12 pi, but with the negative sign. And now it is smaller than minus pi.
मैम
हाँ जी
मैम अगर 13 over 12 pi को भी यूज करें तो आंसर तो सेम ही आ रहा है.
सेम आ रहा है ना, बट अलाउड नहीं होता. आपने अपने पोलर फॉर्मेट में आंसर को पाई और माइनस पाई के बीच में रखना होता है. आंसर तो 100% सेम है, ठीक है, बट गलत लिखा. मार्क्स नहीं मिलेंगे, फाइनल A1 मार्क्स नहीं मिलेंगे. आंसर तो वही आएगा क्योंकि आप रेड एंगल का कॉस ले लो या ब्लैक एंगल का कॉस ले लो, एक्चुअली द सेम एंगल। आप क्लॉकवाइज देखो या एंटी क्लॉकवाइज देखो, द एंगल इज द सेम। ठीक है, मैं आपको कहूँ कि 30 डिग्री प्लॉट करो तो आप यूं प्लॉट कर दोगे 30 डिग्री। और अगर मैं कहूँ -330 डिग्री प्लॉट करो तो उसको भी आप ऐसे ही प्लॉट करो, क्योंकि वो आप यहाँ से यहाँ तक प्लॉट करोगे, सो इट्स द सेम एंगल। If I say 30 degree or if I say -330 degree, it's still the same angle. So you will get the same answer for cos 30, you will get the same answer for cos -330. But you have
ठीक है
to
मैम।
the rules of the topic. All right, so it's going to be 1/4 of cos -11/12 pi and plus iota sine -11/12. This is part E. Now let's do part F, which is find TQ. So since it's TQ, we're going to use De Morbi's theorem. Okay, you have to Q T. So that is very easy. If you're in polar format, what you do, you cube the R, and R here is 1. So 1 cube. And then you multiply this 3 with the angle. So we have cos 3 pi by 4 plus iota sine 3 pi by 4. Okay, so that is it. So we have the answer in polar format. Just in case you're asked to give the answer in the regular form, so then what do? You simply multiply. 1 times cos 3 pi by 4 would be cos 3 by 4 pi is minus under root 2 upon 2 plus iota, multiply 1 with sine 3 pi by 4. That is under root 2 upon. So that would be your answer in the regular form. Okay. Next we have to find, second with the answer check. PQ is correct. Okay, now we have to find T times S steric. What is this? T times S steric. Which is part G. Okay. So T is cos pi by 4 plus iota sine pi by 4. And what is S steric? S steric is the conjugate of S. Remember, we've discussed conjugate before. What is the conjugate of 3 plus 2 iota? What is the conjugate of this? It is 3 minus 2 iota. You simply change the sign of the imaginary part. So what is the conjugate of 3 minus 3 plus 2 iota? It's going to be minus 3 minus 2 iota. Remember, when you're taking conjugate, you have to just flip the sign of the imaginary part, not of the real part. So then conjugate of S is going to be 4 times cos 4 times cos
मैम
minus,
2।
sorry, oh, S करना था, yes, sorry, S का conjugate. So that's going to be 2 times cos pi by 3 minus iota sine pi by 3. Okay. अब थोड़ी सी प्रॉब्लम आ गई है कि we have a negative value here. जो हमने theorems पढ़े थे, they were all for positive values. So now what do we do? I just need a quick second. मैं आ रही हूँ. Okay, I'm back. अच्छा, where were we? Yes, there's a problem here. There shouldn't be a negative sign here. It should have been positive because the theorems we discussed had positive signs here. एक तो ये problem है. Yes, that is our only problem right now. So now to handle that, I want that to be negative. I want this to be positive. अब इसके लिए क्या करना है? You must know these two properties of sine and cos. एक property है कि sine minus theta जो होता है, it's equals to minus sine theta. और एक property है कि cos minus theta is just cos theta. You can check this in your calculator. You can write sine 30, sine minus 30, and it will give you the same answer as minus sine 30. And then you can enter cos minus 30 in the calculator and it will give you the same answer as cos 30. ठीक है, ये रूल्स होते हैं जो आने चाहिए. ओ लेवल्स में भी कराए जाते हैं लेकिन they're not tested much in O levels. So they're still in the syllabus. They are mentioned when you're doing trigonometry, but then they don't ever come up when you're doing past papers practice. So इसीलिए भूल जाते हैं, but ये O levels के भी syllabus में है. Okay, so now let's make use of this property. What I'll do is I'll send this negative sign here ताकि बाहर positive लिख लें, क्योंकि sign minus pi by 3 is the same as minus sine pi by 3. Right? So I'm sending this sign inside. So फिर वो positive हो जाएगा. So let's do that first. So
हम
cos,
दोबारा एक्सप्लेन कर देंगे आप
sorry,
कि ये माइनस इनसाइड क्यों जाता है.
ये property use हो रही है. अगर sin minus theta हो, so it's the same as minus sin theta. ठीक है, कैलकुलेटर में करके देखो. जैसे sin minus pi by 3 will give you the same answer as minus sin pi by 3. They both give the exact same answer. So what I'm doing is I'm sending that negative sign with the angle. ठीक है, इसकी जगह I'm writing this because they give the exact same answers. So sin pi by 4 times 2 cos pi by 3, that negative is going inside. So plus iota sine minus pi by 3. Now this gives rise to another problem with, sorry, बस एक और minute चाहिए. Okay, so अब that gives rise to another problem. जब हम polar form में convert करते हैं तो these angles need to be the same. ये angle और ये angle same होना चाहिए था, पर हमारा तो एक pi by 3 और minus pi by 3 है, so that is a problem for us because this is not the correct polar format. However, we know this property of cos के cos minus theta हो या cos theta हो, the answer will stay the same. So using this property, what you can do here is write this as cos minus pi by 3. It will not change the answer. So now both the problems are fixed. You have a positive sign in between and both the angles are minus pi by 3, which is the required form. Okay, now we can simply add the angles and multiply the r's. So r's, first r is 1, the second r is 2. So 1 times 2 and bracket cos, add the angles pi by 4 minus pi by 3 plus iota sine pi by 4 minus pi by 3. So we're getting 2 times cos 3 pi minus 4 pi is minus pi by 12 plus iota sine minus pi by 4. Let me check the answer. It is correct. Okay. Now please note down the homework questions. This was part G. So you have to do H and I on your own. H is, let me just write that here. So part H is U conjugate upon T square. And we've already discussed what is conjugate. You change the sign of the complex part. So ये negative हो जाएगा, and then that's going to be a problem for you. That you'll fix using the cos and theta rule we discussed today. That's part H. And part I is 4 iota upon U conjugate. अब इसमें double problems हैं. एक तो वही denominator में, since it's U conjugate, there's going to be a minus sign with iota, which you'll fix just the way you'll fix it in part H. The second problem here is that this is not polar format. 4 iota, ये तो regular form है, 0 plus 4 iota, real part is 0, complex part is 4 iota. You will first use the conversion technique we discussed yesterday and change it into polar format before you could divide them. Okay, so both the homework questions are important. Please make sure you do them, or मैं इधर answer भी लिख लूं, and you can screenshot this. और कल इसके आंसर्स अगर आपके सही नहीं आते तो ये फर्स्ट वन इज पार्ट जी, आंसर फॉर पार्ट जी, नहीं जी तो हमने कर लिया, एज एंड आई. आंसर फॉर पार्ट एज इज 4 times cos pi by 3 plus iota sine pi by 3, and answer for part I is cos minus pi by 3 plus iota sine minus pi by 3. Do try these questions. All right, see you tomorrow. Allah Hafiz.